Hey guys, this is Mr. H. Hey, I wanted to do a video on how to find the inverse of any function. Um, so um, I've looked at several YouTube videos on how to find inverse functions, and most of the teachers teach it the traditional way. Um, and I teach it kind of the traditional way with a little twist. And I think the twist makes it a lot easier for students. So I wanted to show you, demonstrate kind of how I teach it and what I'm using. So let me just jump into this because I want to try to do this as quickly as possible. All right, so the title of the lesson is called Into the Multiverse. And this is an homage to Spider-Man, the multiverse, Spider-Verse. I like that. My son and I like that movie, and so it's kind of a play on that. Um, Now I say multiverse, and the reason I say multiverse hopefully will be obvious in a second. The Basically the target of this lesson is to show you how to find the inverse by using PEMDAS. All right, we're going to use PEMDAS, and then we're going to use inverse operations, and then we're going to reverse the order of those inverse operations to find the inverse function. All right, so let me keep going. Now, so what we're going to do that's a little different than what most teachers teach is I'm going to show you how to find the inverses of some operations, and then we're going to do the reverse order of those operations. And when you see it in action, it makes things much simpler. All right, so now the traditional PEMDAS is please excuse my dear Aunt Sally, but I've added please excuse Larry, my dear Aunt Sally. And the reason I'm doing that is logarithms basically are important, and they're basically on the same level as exponents. So I just wanted to throw that L in there for logarithms. So basically the traditional hierarchy is that you always do parentheses first, and then you do exponents second. But in this case, we're gonna put exponents and logarithms. They're both on the same level, so those goes next, third or second, and then third you have the level of multiplication and division. Those are on the same level, and then finally you're going to have addition and subtraction. So when you're looking at a expression and you're trying to determine what should go first, you use this to determine the order. Okay, so now let me see. Now I want to go over the inverses, and I've got a couple examples because this is really important. All right, so if you'll notice, I have add and subtract, and I have a two-way arrow, and that's just to say that addition is the inverse of subtraction, and subtraction is also the inverse of addition. That's why the arrow is going in both directions. All right. Now, and I have an example here. So I said adding 3, the inverse of adding 3 is subtracting 3. And of course, the inverse of subtracting 3 is adding 3. Okay. Now, the second example, or my second level, is multiplication, division are inverses of each other. So I have an example here. I said if you multiply 4, the inverse of multiplying 4 is dividing by 4, and the inverse of dividing by 4 is multiplying by 4. Those, I'm sure most of you know that, very simple. Now, these next few sometimes confuse students. The inverse of squaring something is taking the square root of that something, right? And the inverse of square rooting something is actually squaring something. So the example I have here is 10 squared. The inverse of squaring 10 is to take the square root of 10. Now, you'll also notice I have 10 to the 1/2 power because these are basically the same thing, right? So the square root of 10 is the same thing as 10 to the 1/2 power. Now, if that's not clear to you, what I would suggest is that you go watch a video on rational exponents. I don't have one. I'll probably create one a little later because if I did, I'd link it to you. I'd link that in the video. But if you're not comfortable with that, you need to go watch a rational exponent video. Here's another one. The inverse of cubing something is to take the cube root. And of course, the inverse of cube rooting something is to cube it. So in this, my example is it's 9 raised to the third power. The inverse of that is taking the third root of 9, or the cube root of 9. Or you could say 9 raised to the 1/3 power. Okay, so those are the inverses of each other. Now, this one I've starred because this one is confusing for a lot of students. The inverse of like an exponential function is a logarithmic function, or the inverse of exponents is logarithms, and the inverse of logarithms is exponents. So the example that I got here is 7 to the x power. The inverse of that would be taking the log with the base of 7 of x, right? Those are inverses. And my second example is the log of base 10 of x. The inverse of that is raising, would be having a base of 10 and raising it to the x power, right? So this is really important when you're doing inverses and you have exponents or exponential functions, or logarithmic functions. You've got to be able to find the inverses this way. All right, so now I'm going to do a couple examples and hopefully I'll make this process clear. All right, so I'm going to start with number 2 because I think this is a good problem. All right, now, first thing, if you look at this function, it's g of x equals 2x plus 8 divided by 3. Now, this is what this is called a stack fraction. Now, really what this is, I'm going to rewrite it. It's g of x equals 2x plus 8 in parentheses divided by 2. I'm making that clear because now we're going to use PEMDAS on this. Right, so the traditional way that they teach you is they say, replace the g of x with a y, and then rewrite it. And then most teachers teach you to switch the x and the y. So this would be x equals 2y plus 8 divided by 2. Now that you've got that, what we want to do is we're going to try to get y by itself, and we're going to use PEMDAS to help us do that. So the very first thing that's happening inside the parentheses is we're multiplying the y by 2 right here. So we multiply by 2. The second thing that we're doing is we're adding 8 to y, right? The third thing that we're doing is we're dividing by, oh, this is a 3, sorry. This should be a 3. We're dividing by 3. Now, I'm going to switch the colors because now we're going to take the inverses of multiplying by 2. So the inverse of multiplying by 2 is dividing by 2. The inverse of adding 8 is subtracting 8. And the inverse of dividing by 3 is multiplied by 3. And now, here's the key. Once you've done the inverses, we're going to reverse the order. So this is going to be 1. We're going to do that first. We're going to do this second. And we're going to do this operation last. Now, here is where I think it's much simpler. Once you've done that, the problem is pretty much done. So we know that when we're trying to get x by itself or y by itself, so I got y by itself, and now I'm just gonna, I know there's gonna be an x on the side. So now what I'm gonna do is I'm just gonna perform those operations that we've listed on the x. So I'm gonna multiply it times 3, and then I'm gonna subtract 8, and then I'm gonna divide the whole thing by 2. And I'm done. And what I would do is I would write this with the inverse notation. I would just rewrite it. So 3x minus 8 divided by 2. That's the inverse of 2x plus 8 divided by 3. So we're done. Now, let me go to do another example. I'm going to do number 5 here. So this one says g of x is equal to the 5th root of x plus 2 plus 1. All right, so the first thing that you are taught to do typically is you go y equals the 5th root of x plus 2 plus 1, and then most teachers tell you to switch the X and the Y. Now we've got to get Y by itself. So I'm going to go ahead and come down here and put Y equals, and I know I got to have an X over here. I'm going to just do that. But now in order to get to determine what I need to do, I'm going to use PEMDAS. So the first thing that's happening, and by the way, this one, yeah, the first thing that we're doing here is we're adding 2 right here. We're adding 2 to Y. Now, the second thing that we're doing is we're taking the 5th root of Y, okay? So we're taking the 5th root. And so I just wrote it with a 5th root symbol. And then the last thing we're doing is adding 1 here, okay? So now that I've done that, I've done PEMDAS, I'm going to use the inverse operation. So the inverse of adding 2 is subtracting 2. The inverse of taking the 5th root is to raise it to the 5th power. And the to the 5th power, and the inverse of adding 1 is subtracting 1. Now I'm just going to reverse the order. I'm going to do this first. I'm going to do this operation second, and I'm going to do this operation third. So I go down to the X and I'm going to subtract 1. And then I'm going to take that entire quantity and I'm going to raise it to the 5th power. And then I'm just going to subtract 2. Now let me clean this up a little bit. I'll bring it over here. All right, so now we're finished. We just have to rewrite it with the proper notation. That's it. That is the inverse of the 5th root of X plus 2 plus 1 is X minus 1 to the 5th power minus 2. So that's it. All right, I'm going to do another one. Hopefully you're starting to get the hang of what we're doing. All right, so this one, it says G of X is equal to 2 times the quantity X plus 2 raised to the 3rd power. All right, so the first thing that we're taught to do is we're taught to replace the G of X with a Y and then rewrite it, raised to the 3rd power. And then we're taught to switch the X and the Y. So this is going to be X equals 2Y plus 2 to the 3rd power. Now, I'm going to come down here and just write Y equals, and then I'm going to have an X over here. Now, that part always is going to be true because we got to get Y by itself and we're moving the X to the other side. Now, I'm going to use PEMDAS to help me determine what to do. So the first thing that we're doing to the Y is we're adding 2 right here. And then the next thing that we're doing is we're raising Y to the 3rd power. So I just said raise to the 3rd power. And then the third thing that we're doing is we're multiplying by 2. So now I'm just going to do the inverses. So the inverse of adding 2 is subtracting 2. The inverse of raising it to the 3rd power is taking the 3rd root. And then the inverse of multiplying by 2 is dividing by 2. And now I just reverse the order. This is going to go first. This operation will go first. This will go second, and this will go third. So I'm just going to do those operations on the X. So the first thing that I'm going to do is divide X by 2. Bam, that's done. Check it off. Next thing I'm going to do is I'm going to take the cube root of all of this stuff. So I'm going to do this and put it in a cube root. It's done. And then I'm going to subtract 2 from it. And we are finished. Well, almost finished. We just have to write the notation. And we're done. That's it. So let me go back through this. I'm going to do one more example with log, but I just want to go back through this. So you're always using PEMDAS here, right? And actually, we should put an L in there for logarithms. We'll see that. So we're using PEMDAS to find this part. and then we use the inverse operation, and then we just reverse the order. That's why I call it multiverse. We're inversing and reversing. All right, now I'm going to do one more problem, and this one is a logarithm. All right, so this is number 16. I'm going to move this up, move this over. All right, so now this one doesn't have, it's not a function notation. It's just y equals log of the quantity x minus 8. So we don't have to do the y step. We're just going to start by switching. So I'm going to say this is x equals the log of y minus 8. Okay. And again, I know down here, I'm going to have y equals, and I know I'm going to have an x, but I'm using PEMDAS. So I'm using PEMDAS here. So the first thing, and by the way, this one only has 2 operations, so I don't need this one. So the first thing that we're doing is the stuff inside the parentheses. So we are subtracting 8. So since there's parentheses, we do what's inside the parentheses first. And then we're going to take the log, and this has a base of 10. So we took the log of x with a base of 10, and now we're just going to do the inverse. The inverse of subtracting 8 is adding 8. The inverse of log with a base 10 is having a base of 10 and raising x up. All right, and now we're going to reverse the order. This we're going to do first. This operation we will do second, and then we will be done. So we're going to take the x and we're going to put it as an exponent with a base of 10. That's the inverse of log with a base of 10. All right, so that's done. Now my second and final step is just to add 8, and it's done. That's the inverse. There's nothing else to do there. Of course, you have to know the inverses, but once you know the inverses, you just use PEMDAS and then reverse the order, use PEMDAS and then do the inverse operation and reverse the order, and you're finished. All right, I hope that this has been helpful. Let me go back and recap what we're doing here. This is a little long, but sorry, hold on, guys. All right, so what we're doing is we're using PEMDAS to get y by itself. And then we do the inverse of whatever the PEMDAS operations are. And then we reverse the order, and then we'll be done. That's it. I hope this has been helpful. If you have any questions about anything that I've done in here, just leave it in the comment section and I'll try to get back to you as quickly as I can. Again, I hope that this has been helpful. I think this is much easier if you know PEMDAS than the kind of traditional way. All right. Thanks, guys.